Hello, hi, welcome to my channel. So today I have picked another interesting problem from LeetCode, which is single-threaded CPU. So in my last video, I have solved similar related problem, which is like task scheduler. So I picked this one because it's a little invariant of that problem. In that problem which I have solved in last video, that was like we need to find out the total time required to complete all tasks, but this is different one. uh, so that's why I picked this problem. So let's read the problem first, and then we will approach this problem and build the intuition, then we'll solve and submit on LeetCode. Okay, so let's jump into the problem statement. So this is what I have in last video I have like solved this one problem. So where we need to find out, like, return the minimum number of CPU interval required to complete all tasks. If you haven't watched this video, you can go and you must watch this video. This is interesting one. And okay, so let's jump into the main problem, which is the single threaded CPU. So in single threaded CPU, there are like a description given. So you are given a task labeled from 0 to n minus 1, represented by 2D integers. So, and so if I tell you the like problem statement in one line, so before reading all the description of this problem, so if you can search on Google just single thread CPU, you can find it this link on for LeetCode. You can attempt that, and let me tell you what the problem statement is in this. Okay, so we have a given a task where we have a in queue time. Okay, in queue time for each task and processing time. Okay, so similar this way we have a list of tasks. Okay, similar so on. And we need to find out, and we have a single threaded CPU, means one core CPU we have. Single core CPU, what single threaded, right? Single threaded CPU. And there are like given a condition, if CPU idle and there is no available task to process, then CPU remain idle. Okay, and if CPU idle and there are available tasks, case 2, if CPU idle, okay, idle, and we have available task to process, then it give the first priority of the task which have the minimum processing time. Okay, means shortest processing time. It will first pick that task to execute. If it die, means multiple tasks have same processing time, then it will pick the on arrival time, means which arrive first, that will be first. Okay, so that the condition. And so once CPU started, it will process the entire task. So it will not it like it will not quit in between while executing any task. Okay, and so we need to return the order of which CPU will process the task. So the final answer that we need to return the index, means order in which the task is processed by the CPU. Okay, with this given required condition. So this is the example. If you see, so at time 1 start, it picked first task, and when then it picked second and picked third, then it picked zeroth index task, and then it picked second, then it picked and fourth one, which is third index, then it picks second one which is at first index. Okay, so similarly for example 2, and the constraint from 1 to 10 to power 5, task length can be go to up to 10 to power 5, and include and processing time can go to 10 to power 9. Okay, so if I tell you in simple way this why what is this. So suppose starting, when it which task will get pick first, right? So s- is- if you see the constraint in queue time can go 1 to 10 to power 9, right? So we can definitely say that starting time we can take CPU start CPU start executing at time 1, time is equal to 1. Okay, so at time 1, if it get any task available, then it will start execute that, and it will process until in queue time plus processing time, right? If I tell you in simple way, in not in general way, like CPU will be available after picking a task available at in queued time plus processing time. Okay, so is start at include time, it will take the execution whatever the processing time. Once it get finished, then it will be available to pick the next task. Okay, so if you see the this example, uh, second one, if you see at time 7, before 7 there is no task available to execute, so CPU will remain idle till 1 to 6. Time 1 to 6 CPU will be remain idle, that won't any contribution in that. Okay, so at 7 it CPU see there are 4 tasks available, right? 1 2 3 4 5, there are 5 tasks available, right? And at time is equal to 7, which is equal to include time, and then CPU pick the task as per the this condition. If you see at time 7, what is the which task have the is shortest processing time, that is the fifth one, right? At fourth index, so that will it will pick. So once it will picked, then when it will be available as 7 plus 7 plus 2, right? At 9, time is equal to 9, it will be available. But meanwhile, whatever the task is available to execute, that will be uh, put into available queue. So if you see all the task is available, then it will be, then if you see all the tasks are available, then it pick the smallest one. After this, it will pick the smallest processing time, that is the uh, fourth one, which is third index, and then it will pick the third one, which is a second index. Then it will pick the first one with a zeroth index, and similarly second one, which is that first index. This is the way it will pick. So what the challenge? Suppose while while CPU processing a task, and and it will be available at this time, right? Within this time, then in between whatever the task are available to execute, then we will put into available queue so that we can fetch the smallest one which have the shortest processing time. If tie, then it will pick the according to the arrival time. So we will require the priority queue, right? Why priority queue? Because we need a smallest one among all the available tasks. Is shortest processing a task which has shortest processing time. Okay, among all available tasks. So let's write code for it. So let me just what I will require first. I will require a priority queue where I will put a task which will be which get available uh, while processing a task. Okay, so I need a what I will need a processing time into a priority queue and plus its index. So if any case processing time get tied with another task, then it will sort by the its index. Okay, so we need two data, one processing and one index. That's why I have taken the int array. Okay, so we define a table label task equal to new. I just copy it priority queue as over here. Okay, so I will just let me just define the priority queue is by default is min order, min heap. Uh, so, but we need to define the custom sorting so that it will sort on second field if we get tie, right? So if a0 processing time of first task and processing time of second task is equal, then return integer dot compare and sort based on the arrival time a1 and b1. Correct? A is just return the if it not tie, just sort based on the processing time, which is the smallest one will pick first. Okay. So what are other things I need? I need to sort that task so that I can pick the uh, smallest one first, right? Smallest one means which in queue time is shorter than the other task, so that it will start from the a task which has the smallest uh, queue time, right? We just first I will define the and which give the size so that I can reuse again. Okay, so I need uh, pairs, right? Let me define the pairs. So new and I need three data. I will tell you one for the include. Uh, I will keep the include and processing plus index. That's why I need three. Okay, so let me just put it here. Just copy it index and I is equal to 0 to I less than and I plus plus. So pairs and add first index. So I will just put the task I means this is in queue time, right? And second one is the processing time. Okay, that I will put here. I am defining because I need index, right? So that otherwise I won't need this array. So when I will sort, original index will get swapped so that I need to track that index. That's why. So once we have include processing and its original index, then we can sort easily. Arrays dot sort. Just pass the this and apply the custom sorting. Here also just passing the which field I am going to sort. Integer dot compare. I'm sorting based on the arrival time. Nothing else. Okay. Once it array is sorted, just start with the, let me define the include time. CPU available, CPU available at start from one. Okay. Also, I need answer that I need to return. And so let me define as answer result or answer new and n. Okay. So I need a one variable like start from 0 and also need a k for uh, updating the result. Okay. So while I less than the pay n. Okay. While what I will do now. Now array is sorted means pairs is sorted. Okay, all task is sorted with their original index. So and pairs dot I when its include time is less than the CPU available at. So we just need to put into a available task. Okay, just put the available task dot offer. What I need to put? I need to put its processing time and its original index on which we need this priority queue will sort. Okay, that's the one and second, which is the second is the index, right? Okay, just take the I plus plus. Okay, so if priority queue is not empty, okay, so I will uh, pick any available what is the smallest one. It give the smallest one. We pick that task means executable executable task. What is the executable task? It will the top of the this available task. So means which have the task which have the smallest processing time or either it's the smallest arrival time, that is the executable task. So I need to just update the, so it give the index which order it getting to execute, that is the if you see that is the second one, right? Also I need to once it CPU start executing this available task, then CPU available at next time. What will be next time? It will be available at, it will be available at uh, whatever the is the processing time. Just add into duration into CPU time. That time it will be available. So when no more task is available to execute, then we just advance our pointer means CPU just set to the what is the smallest means um, first one that I can pick, that is the this one, right? Just update with this. I hope you understand. Suppose CPU we don't have any available task in CPU. So instead of going one by one like say, doing in else case, what you do in else case you do right plus plus you go one by one. Oh, you see, a second example, first task is available at 7, but starting from 1, you wasting time going 1 to say 6, where no task is available. So just jump into the first available task, which will give the either this one because it already sorted pairs. means task is sorted by this arrival time, means in queued or arrival time. Okay, so that's it. So what I need to do until we have available task. So we do it here again, and at the end just return the result. Okay, let me just run it. It will get expected line number 6. Okay, so what is expected? Okay, that's semicolon is expected. Okay, so for sample test cases, it got passed as expected. And let me run it. So I think let me submit it to run all the test cases. Hopefully, yeah, now it's accepted. Okay, so this is all about this one, this problem statement. So you go as the problem statement says. You don't need to like bother in any other extra complexity. So if you see, I have written the like go as it is what the problem statement is says. So that's it. Yeah, happy coding.